Let's open up this second part by doing some examples of writing balanced equations from Word. Let's open up by writing balanced equations from Word documents like we did with that last example. So here's the first one. Lithium sulfate, barium chloride produces barium sulfate and lithium chloride. Again, let's write the four compounds first. Lithium and then sulfate is one of those polyatomic guys that you're supposed to know. And that's going to be added to barium chloride. Write the symbols down first and we'll come back and put the subscripts in just a second. Forms barium sulfate plus lithium chloride. Okay. Lithium is a +1, sulfate's a -2, least common multiple is 2, +1 goes into 2 2 times, 2 goes into 2 1 time, so that's the way it is. Barium is a +2, chlorine is a -1, least common multiple is 2, so 2 goes into 2 1 time, and 1 goes into 2 2 times. Barium again is a +2, sulfate's a -2, so they're okay the way they are. Lithium's a +1, chlorine's a -1, so they're okay the way they are. Now over here we have 2 lithiums and 2 chlorines, but over here we only have 1 lithium and 1 chlorine, so we need a coefficient 2 to balance this equation. The next one says hydrochloric acid plus zinc produces zinc chloride plus hydrogen gas. Okay, hydrochloric acid is HCl plus zinc is just Zn, forms zinc chloride plus hydrogen gas, and hydrogen is one of those polyatomic ions that forms or diatomic molecules. When it is by itself, it's not just H, it's H2. The other one's it's H2, another one's O2, another one's F2, another one's N2. And these exist in nature as polyatomic or diatomic molecules. Zinc's +2, chlorine's -1, least common multiple is 2. 2 goes into 2 1 time, 1 goes into 2 2 times, so we need a 2 there. We have 2 chlorines here and 2 hydrogens here, and then we only have 1 of each here, so we need a coefficient of 2 there. The next one says electricity is applied to water, producing hydrogen gas and oxygen gas. Okay, so you start with water and you form hydrogen gas and oxygen gas. You see that you have 2 of these and 2 of these. That's okay, but you only have 1 here and you've got 2 over here, so you need a 2 here. But now that gives you 4 of these, so you have to put a 2 here as well. And now it's balanced. And you can put E right here if you want to represent the electricity that was applied. You don't have to do that. Carbon dioxide plus water produces glucose plus oxygen. So carbon dioxide, it's telling you what the formula is right there, plus water forms glucose, and I gave you the formula for glucose there, plus oxygen, and oxygen is one of those diatomic molecules. So you have 6 carbons here and only 1 here, so you need a 6 in front of this guy. You have 12 hydrogens here and 2 here. 2 goes into 12 6 times, so you need a 6 there. So you have 2 times 6 is 12 oxygens here, and 6 times 1 is 6 here, so the total oxygens is 18. You have 6 here and 2 here, Now you don't want to put any numbers in front of this because that changes all these, but you can subtract this 6 from here, and that leaves you 12. 2 goes into 12 6 times, and now it's balanced. So that's how you do those word equations to regular equations. Now there are some special symbols that can be used to show special things that have occurred during the process of chemical reactions. For example, if you have a liquid and you pour another liquid in it, but a solid is formed, that's called a precipitate. It's a solid that's produced by a reaction that settles into the bottom of the container, and that can be shown by putting a little arrow, a downward arrow, beside the chemical compound that represents the solid. If a gas is produced, you can put a little upward arrow beside the gas. So in our last example, we could have put upward arrows beside, say, the hydrogen gas that was produced and the oxygen gas that's produced. If heat is added or is a product of a reaction, you can use the delta symbol to represent heat. And then sometimes they use subscript little lowercase letters to represent the physical state that any particular compound is in. So for example, if you have oxygen gas, you'll have O subscript 2, and then beside the subscript 2 will be a little g in parentheses. And that tells you that the oxygen is a gas. Or in the last case we said zinc, if zinc's a solid, you can write Zn and then a little subscript S in parentheses. Aqueous just means that it's something that's dissolved in water and has formed ions. Now let's talk for a minute about the types of chemical reactions. The first type of chemical reaction is called a composition reaction. A composition reaction is when two or more substances come together to form a more complex substance. And here's an example. You have two zinc atoms which combine with a diatomic oxygen molecule to form two zinc oxide molecules. This is the composition of zinc from its elements. Zinc oxide from its elements. The opposite of that is the decomposition reaction, where a complex substance is broken apart to form simpler products. And here's an example of that. This is potassium perchlorate. Actually, this occurs when you apply heat to that. It breaks apart to form potassium chloride and two oxygen molecules. A single replacement reaction occurs when an element in a compound is replaced by another element in a compound, and it only occurs, there's only one replacement, thus the name single replacement. So for example here, zinc combines with barium sulfide to form zinc sulfide plus barium, and the zinc replaces the barium in barium sulfide. So there's a single replacement of the zinc for the barium, and that's called a single replacement reaction. And a double replacement reaction is when the two compounds swap anions and cations. So for example, you have potassium chloride combining with lithium nitrate to form potassium nitrate and lithium chloride. The potassium and the lithium just switch partners, sort of like a square dance where the two cations switch partners and end up with the other anion. So let's do examples and see if we can identify the type of reaction in each of the following. Now here we have potassium chloride plus magnesium goes to form magnesium chloride plus calcium. I'm sorry, I said potassium first time. It's calcium chloride plus magnesium forms magnesium chloride plus calcium. And what you have here is the magnesium replacing the calcium, and it's a single replacement. So this is a single replacement reaction. And here we have the equation we talked about, or the process we talked about before, where water is electrified and breaks apart. It's actually called electrolysis. It breaks apart into hydrogen and oxygen. And this is a classic decomposition reaction where a more complex molecule is broken apart to form its less complex elements. And here we have barium sulfate plus zinc oxide forms barium oxide plus zinc sulfate. And now we have the square dance again, where there's a switching of partners. So this is a double replacement reaction. And here we have Fe, iron, plus oxygen forms iron 3 oxide. This is a composition reaction forming iron 3 oxide from its elements, iron and oxygen. Thermodynamics is the study of heat in reactions, or heat exchanges in relationship to chemical reactions. An endothermic reaction is a reaction that requires the input of heat in order to proceed. An exothermic reaction is a reaction that produces heat as it proceeds.